Welcome back, everyone. In this lecture, we're going to discuss Pandas series. A Pandas series is very similar to a NumPy array, except for the addition of a named index. We can use this named index to grab data from the array. This works really well with real-world data, where every row is usually associated with some sort of named index object. So let's see how this all works with Python. I'm going to head over to a Jupyter Notebook now. To begin, I'm going to import NumPy as NP, and by convention, we import pandas as PD. So first, we're going to show you how to create a variety of series using a variety of different base Python objects. So first, I'm going to define a couple of things here. I will define a normal Python list, just called labels, ABC. And then I will say my list is equal to 10, 20, 30. Another variable I will create is a NumPy array. So we'll say array is equal to np array, and essentially pass in that list. And then finally, I'll also create a dictionary. And a dictionary is going to look really similar. It's going to have A as a key, 10 as a value, B as a key, 20 as a value, and then C as a key, and 30 as a value. So we have these four essentially basic data structures. And each of these we can actually convert to a Pandas series. So if we say pd.series, you should be able to then do Shift-Tab after you've already imported pandas PD and see the general documentation string and the signature. And while there's a lot going on here, the two main things we need to be aware of for a Pandas series is the data parameter and the index parameter. So first, let's go ahead and provide data for the series. And I can do this by saying data is equal to, and in this case, let's just pass in that normal Python list. And here we can see the way Pandas outputs a series inside of the Jupyter Notebook. By default, the series is going to have a labeled index, and if you don't provide an index, it will by default show you the numbers starting at 0. So it'll say 0, 1, 2. And this is quite similar to essentially what NumPy or even a normal Python list does. But what I can do, and this is basically the difference between a Pandas series and a normal NumPy array, is I can have a labeled index. So I can set my index equal to that labels list. And now I can see I have a Pandas series where each row has a label to it, A, B, and C. And later on we will be able to explore that I can still actually identify the items in my series by their actual integer location. So essentially now I have two ways of grabbing items based off an index, either based off the index name or based off the index location, such as location 0. So keep in mind, I don't actually have to say data equal to or index equal to, as long as I provide this in the correct order. If I rerun this, notice I get back the exact same results. And this is going to be the same for if you're working with a NumPy array. So we say PD series array, we can see that's the same thing. And I can also then pass in labels to label that data. Now, while we usually won't be passing in dictionaries in this fashion, if you do have a dictionary with keys and values, you can quickly transform it to a series by running pd.seriesd. Later on in the course, we're going to see that the way TensorFlow actually returns back a history of losses, being able to convert it quickly to a Pandas series is going to be really useful. So keep this in mind that we will see this later on in the course, even though throughout the Pandas section, it won't be too common to run this. Now you've been hearing me say a lot that the key factor of a Pandas series is the fact that it has this labeled index. So let's go ahead and build out a more complex series. We'll go ahead and call this sales Q1 for maybe first quarter sales. And this will be equal to a Pandas series where the data is equal to, I'm just going to make up some numbers here, 250, 450, 200, 150. And then we'll go ahead and have the index maybe based off some geographical locations. So maybe we have quarterly sales data for different countries, like USA, China, India. Make sure this is a comma here. And let's pass in one more just to make sure the dimensions match up. We'll say Brazil. So we need basically one index per data point. So we'll go ahead and run this. And if I take a look at sales Q1, here we have this sales data. Now let's go ahead and make this for sales Q2. Again, kind of just going to make up some data here. We'll change this to sales Q2. I'll change these numbers around a little bit, maybe 260, 500. Go ahead and just make this, let's say 210 and 100. Now for the index, this is probably the more important part that we're actually going to change. I'm going to change this last one from Brazil to Japan. And I'm going to see sales Q2. Okay. Now, when we're working with realistic data sets, this is essentially the kind of thing we're going to be working with, where we have some sort of named index and then some value or feature corresponding to it. Now, what I want to show you is how you can actually grab information off of this series. So because this is now a labeled index, what I can do is, let's say I wanted to know the sales in Q2 for China. It's essentially almost like a dictionary call, where I would say sales Q2, and then in braces, pass in the string China, run that, and it will return back the corresponding number. And we can confirm that by taking a look at sales Q2. Now, if for some reason you actually wanted to grab information based off the index location, as in the integer-based location, what you could do is pass in that location, such as the very first item at 0, and it would still work. So we can see sales Q2, and that returns back 260 if you call for 0. So note that whether you call USA or if you call sales Q2 0, it returns back the same value. So that gives you flexibility with the Pandas series. If you have a named label, you can call the index based off that named label. If not, or even if you do have it, you can always call based off the integer location of a series. So you can essentially do what looks like a dictionary call or a list index call. Now, something I want to show you is you may get an error if you try providing something that's not in there. So if I try to ask for the 10th item in the series, I'll get a key error. And key errors are really common for beginners to get. And basically what this indicates is either you provided the wrong number. So you'll notice here it says key error 10. I couldn't find it because I don't have 10 items. Or maybe you committed a typo, such as typing USA in lowercase, in which case that will also produce a type error or key error. We can see here that produced an error as well. So just be careful with that. You have to spell things correctly, and capitalization actually counts. Last thing I want to show you is we can then perform operations between series. So I can take sales Q1 and try adding it to sales Q2. Now keep in mind, if we take a look at sales Q1, I have this item Brazil, which is not present in sales Q2. So what's going to happen is the default behavior when I add these two series together is for Brazil and Japan, it'll say basically not a number, since it didn't have information for both of those named labels for both series. Later on, we'll go ahead and show you how to change this behavior to maybe treat one of the series as a 0 in order to keep the original values. So if you wanted to see Japan as 100 here and then Brazil as 150 in the final result, we'll show that later on. But what I want to basically point out to you here is that even if you're adding two series that don't match up perfectly based off their index labels, the operation will still go through. It'll just basically notify you of where you only had information on one of those series by providing not a number. So if you saw this final result, this basically tells you that Brazil was only present in one of the series. Same with Japan. Okay, that's the very basics of Pandas series. Coming up next, we're going to walk you through the real workhorse of Pandas, which is the data frame. And that's really what we're going to be using throughout most of the course. I'll see you at the next lecture.